Scientists just discovered something happening 3,000 miles beneath your feet that nobody saw coming.
That recently, with some claiming that our planet's core has stopped spinning.
Suspended in that thick liquid of the outer core, it doesn't have to spin at the same rate as us here.
Seismic waves from earthquakes passing through the planet's core reveal the solid iron ball at Earth's center has reversed direction, now spinning backward after slowing down around 2010. And this reversal is connected to the one thing keeping every living organism on this planet alive. But the reversal isn't what has researchers warning about planetary stability. A second study, published in February 2025, revealed something even worse. The core isn't just spinning backward, it's changing shape, deforming at its boundary in movements resembling landslides 5,000 kilometers below the surface. And what triggers these changes? The churning liquid iron that generates Earth's protective magnetic field means the shield protecting us from deadly solar radiation is being affected by forces nobody fully understands. And when these changes could cascade into something catastrophic remains completely unknown. If you care about what's really happening at the center of the planet, and why changes to the core could affect the length of our days, Earth's magnetic field, and the long-term evolution of life on the surface, share this everywhere. Because what seismic data revealed in 2024 and 2025 doesn't just prove the core reversed spin after decades of spinning faster than Earth. It proves the deepest part of our planet is far more dynamic and unpredictable than anyone imagined. And if the core is changing this rapidly now, what happens when the forces driving those changes accelerate? Before we break down exactly what seismic waves revealed about the reversal, why the boundary between the solid inner core and liquid outer core might be as soft as jelly, and what it means that the surface of the inner core may be developing bulges, rising and falling by kilometers in processes nobody fully understands. Subscribe to this channel for the investigations that expose what's really happening beneath the surface. First, you need to understand what Earth's inner core actually is, because it's one of the most extreme environments in the solar system. Deep inside Earth is a solid metal ball that rotates independently of our spinning planet, like a top whirling around inside a bigger top. The inner core is a hot, solid ball of iron, roughly 1,500 miles wide, about 70% the size of the Moon. It sits about 3,200 miles, 5,150 kilometers deep, surrounded by an outer core of liquid iron and nickel. The core was discovered by Danish seismologist Inge Lehmann in 1936, and how it moves, its rotation speed and direction, has been at the center of a decades-long debate. Part of the trouble is that Earth's deep interior is impossible to observe or sample directly. Seismologists have gleaned information about the inner core's motion by examining how waves from large earthquakes that ping this area behave. Differential rotation of the inner core was proposed as a phenomenon in the 1970s and 80s, but it wasn't until the 90s that seismological evidence was published, said Dr. Lauren Wazek, a senior lecturer of physical sciences at James Cook University in Australia. However, interpreting these findings has been contentious due to limitations in observing and collecting accurate data. Then in 2023, one hypothesis suggested that the inner core, which had once spun faster than Earth, was now spinning slower. Research from January 2023 indicated that the solid metal core of Earth might have reversed its spin as part of a decades-long pattern of slowing down and speeding up. In June 2024, new research from an international team of scientists confirmed these findings. We've been arguing about this for 20 years, and I think this nails it. I think we've ended the debate on whether the inner core moves, and what's been its pattern for the last couple of decades. Dr. John Vidale, a Dean's Professor of Earth Sciences at the University of Southern California's Dornsife College of Letters, Arts and Sciences, told CNN. Here's what the research revealed. The research team used earthquake data for a 2024 study to resolve a long-standing debate over the inner core's rotation. They found that the inner core once spun faster than Earth itself. But beginning around 2010, the solid inner core's spin slowed. It's now revolving backward relative to the rest of the planet. The study, published in Nature in June 2024, was based on readings from 121 repeating earthquakes originating near the South Sandwich Islands between 1991 and 2023. They also tapped into data from Soviet nuclear tests conducted between 1971 and 1974, as well as repeated French and American nuclear tests. By tracking seismic waves from earthquakes that have passed through the Earth's inner core along similar paths since 1964, the authors found that the spin followed a 70-year cycle. By the 1970s, the inner core was spinning a little faster than the planet. It slowed around 2008, and from 2008 to 2023 began moving slightly in reverse relative to the mantle. Vidal attributes the pace shift to the churning of the liquid iron outer core that surrounds it, which generates Earth's magnetic field, as well as gravitational tugs from the dense regions of the overlying rocky mantle. But here's where the discovery becomes truly disturbing. In February 2025, the same team published a second study, this time in Nature Geoscience, bringing an even more surprising result. When analyzing approximately 200 pairs of earthquakes recorded between 1991 and 2024, the researchers identified subtle differences in the seismic waves detected in Yellowknife, Canada, which did not appear in seismic stations in Fairbanks, Alaska. If the only change in the core were rotational, both stations should have recorded similar patterns. They did not. The interpretation most consistent with the data was that the surface of Earth's inner core may be physically deforming. It's almost science fiction to visualize what's happening on the surface of the inner core, Vidal said. It's a place that's so different from our day-to-day lives, with different time scales, different materials, and incredible forces. The scientists analyzed 168 paired waves from quakes in 42 locations near the South Sandwich Islands. Signs of the core's deformation appeared in waves from earthquakes that were strong enough to reach Earth's center. Amplitude changes in a type of core-penetrating P wave, PKIKP waves, hinted at deformations in the inner core's shallowest level. At the boundary where the solid inner core meets the liquid of the outer core, the sphere's surface might be more malleable than it is at deeper levels. Even though that inner core part is really solid, this boundary is really soft, explains study co-author Guaning Pang, a geophysicist at Cornell University. Maybe as soft as jelly. What that deformation might look like is harder to pin down. Maybe the topography is going up and down. Maybe it's sloughing around like landslides, Vidal said. The most likely thing is the outer core is just pushing on the inner core and moving it around a little bit. The study suggests both factors are at play, changes in rotation and physical deformations at the boundary. Some of the waveform changes are linked to the core's rotation, while others appear to result from the outer boundary of the inner core developing bulges. It's possible that the entire inner core is deforming, like a football being reshaped so its ends point in two new directions. Alternatively, patches of the inner core's surface may be swelling or contracting, like small bumps and dents forming on the metaphorical football. The team found that between 2004 and 2008, waves traveling to Canada's Yellowknife station changed unexpectedly, while those reaching Alaska remained consistent. This suggests that the inner core is not a perfect sphere, but instead shifts over time, with certain areas rising and falling by kilometers. Since iron melts at around 1500 degrees Celsius, Vidal believes the boundary between the inner and outer core may constantly melt and refreeze, forming new structures. Another possibility is that iron is bubbling up from the inner core's surface like a burp, or the surface of the inner core is becoming rougher and more uneven due to the pull of gravity and the movement of the surrounding molten outer core. Here's why this matters, and why it should terrify you. The tumultuous outer core exerts a force on the spinning inner core, which can cause it to change rotation and shape. The inner core also grows slowly over time, as the iron in the outer core crystallizes onto it. This process drives churning in the outer core, which sustains Earth's magnetic field. The sloshing of metal-rich fluid in the outer core generates electrical currents that power Earth's magnetic field, which protects our planet from deadly solar radiation. Changes in the inner core's rotation can also affect the length of our day. Investigators think these forces may slightly affect day length. It's very hard to notice, on the order of 1,000th of a second, almost lost in the noise of the churning oceans and atmosphere. But the implications go deeper. A slower spinning core could potentially affect Earth's magnetic field, a protective shield safeguarding the planet from deadly solar radiation. Earth's magnetic field isn't set in stone. It's alive, experiencing changes and even pole reversals, the magnetic north and south trading places. This hasn't happened for a few 100,000 years, but who knows when it might occur again. Regarding the impact on life, inner core growth plays a crucial role in generating Earth's magnetic field, which protects us from harmful solar radiation, said study co-author Takashi Miyazaki. While a direct connection between life on Earth's surface and the inner-outer core boundary remains distant, what happens at the boundary still has some implications for Earth's long-term evolution. And there's a long-term concern nobody wants to talk about. As the liquid outer core shrinks, millimeter by millimeter, the inner core has siphoned molten metal from the liquid core surrounding it. It likely took billions of years for the inner core to cool and solidify. And over the next few billion years, the inner core will continue to cool, sipping drops of liquid metal from the outer core, until Earth's entire core is a solid metal sphere. That'll kill the magnetic field, Vidal said. There won't be the moving iron down there anymore. However, such an event is billions of years in our future. But the fact that the core is already reversing spin and changing shape means the timeline for these processes might not be as stable as models assumed. After decades of research and debates, we are coming to an ever clearer picture of the changing inner core, says Xiaodong Song, a seismologist at Peking University in Beijing. But that clearer picture reveals something unsettling. The deepest part of our planet is far more active and dynamic than once believed. The research team believes that following waveforms from future quakes could unlock details about how Earth's center changes over time. One thing is absolutely certain. Seismic data confirmed the inner core reversed its spin, slowing around 2008 and moving backward relative to the surface by 2023, following a 70-year cycle. A second study in February 2025 revealed the core is also changing shape, with its surface deforming at the boundary with the liquid outer core. The boundary may be as soft as jelly, with areas rising and falling by kilometers, in movements resembling landslides 5,000 kilometers beneath the surface. These changes are driven by the churning liquid outer core that generates Earth's magnetic field. Changes to the core could affect the magnetic field protecting Earth from solar radiation and the length of our days. Billions of years from now, when the outer core solidifies completely, the magnetic field will die. We discovered the core reversed spin and is changing shape. What we don't know is whether these changes are accelerating, or what happens when the forces pushing and pulling at Earth's molten heart finally tip the balance.